Okay, the primary topic for today and for next meeting too is the notion of experimental error, or error, E-R-R-O-R. I can't say any other way. Experimental error. And we will look at that in some detail momentarily. Let me ask first, are there any questions about assignment 5 in particular, or interval estimation in general? This is your last chance. If you don't ask questions now, I don't want to hear the words interval estimation from any of you. Yes.
I just had a question about the multiplication on number 7 on when you calculated it at 95%. When I got to one of the very last steps where it was 0.1897, then you did plus or minus, you had 0.0575, but when I did the multiplication and I did 1.96 times the number that we were supposed to do, I got a different number, so it threw my final solution.
Was it
off
vastly different?
Not too different, but a little bit off. And so I thought maybe...
I can't guarantee the accuracy of those answers. I could have been in a drug-induced haze.
Because I did it like 2 or 3 times.
That's not true, particularly since we're on TV. Obviously, I can make mistakes too as I go through them. I check them, but as you know, once you've made a mistake once, it's very easy to make the same mistake again because you've got the thing in your head. I would not worry if you are a small amount off. If the discrepancy is large, then there's a problem. The primary issue is, do you feel comfortable working your way through those problems? And if the answer to that is yes, I would be minimally concerned with the problem that you have, particularly if you arrived at the same answer as on all the other questions. Are there any other questions, either about assignment 5 in specific or interval estimation in general? No? Then let's talk about experimental error. And for this, we need really, in a sense, to jump ahead a little and start using a language that is associated with experimentation and hypothesis testing, rather than the language that we've been using that's associated with interval estimation. But I'll try and demonstrate how these two languages are linked together. The first idea that you need to be introduced to is the Null Hypothesis, represented by H subscript O, or H subscript 0. The Null Hypothesis. Now, the Null Hypothesis can be expressed in a variety of using a variety of symbols. That is, it can posit relationship, in fact no relationship, between a variety of combinations. But certainly one of those is between the population mean and the sample mean. So an example of a null hypothesis would be that mu equals x bar. If, for example, well, let me start this analogy from the outset. The analogy to the null hypothesis in social research is the assumption of innocence in a court of law. The assumption of innocence in a court of law assumes that the defendant made no significant difference, had no significant effect on the stream of events. Yes. If we, in a social research context, think in terms of the rate at which people are victims of violent crime in the population, we might surmise, and we know the value of mu, that is, we know the frequency with which people in general are victims of violent crime. We might argue that the older you become, the more vulnerable you are to violent crime. Older Americans offer fewer defenses, fewer physical defenses, and so forth. And we could argue that because of those attributes, elderly Americans are more likely to be the victims of violent crime than Americans in general. And to test that, we might then reach into and identify a sample of older Americans and compute X bar. That is, compute the average frequency with which those older Americans have been the victims of violent crime. In this instance, the research hypothesis, represented by H subscript 1, the research hypothesis, would you agree, would be that mu is less than X bar. What we would be arguing is that the average rate of violent crime in the population is less than the average rate of violent crime amongst elderly Americans. Yes? Is there proof of life out there? If we were to follow this logic and present it in a formal way, that is, as a research hypothesis, we would be hypothesizing that mu, which represents the frequency with which people in general are victims of violent crime, would be less than X bar, where X bar represents the frequency with which a sample of elderly Americans are the victims of violent crime. This is simply an example of a research hypothesis here. The argument here is that age makes a significant difference to the flow of events. The null hypothesis, again, would be that age makes no significant difference to the flow of events. That is, just as in a court of law, there is this, there are several things that happen in life that we respond to in an automatic way. You hear that siren going, and you look in your rearview mirror, and there's an ambulance or a fire engine, and you pull aside, you pull over, except on the East Tex Freeway, where we just put our foot down and go faster, and then drop in behind the ambulance or the fire truck, like they're just clearing a path for us. So that automatic reaction will soon die, and it will die first on the East Tex Freeway, but this reaction never will. And you know how many centuries this has lasted? The sneeze and then God bless you. It's like, it's the plague. It's the plague. You know? We will never stop this. This is just one of those things. You do it with strangers. You know, you're standing there at the zoo. The person next to you watching the gibbon goes, "Choo," and you say, "God bless you." And they say, "Thank you very much." It's very humanizing. The analog here, yes.
Okay, so the thing is, like the research hypothesis, it talks about like the correlation, and the null hypothesis, it doesn't like have a correlation or whatever. Is that what you're saying?
The research hypothesis, by analogy, is represents what is in the head of the prosecuting attorney. The prosecuting attorney believes that the defendant made a significant difference to the stream of events. However, the assumption that is being tested in a court of law is not that. It's an assumption of innocence. It's an assumption that the defendant had no significant impact on the flow of events. Exactly the same situation obtains in social research. We can distinguish between what is in the head of the researcher, which is some statement of difference. Here I've tried to offer the hypothetical example involving the frequency with which the population in general are victims of violent crime versus a sample of elderly Americans. But clearly researchers make a great many hypotheses of difference. If, for example, you argue a modeling effect amongst television viewers, and particularly children, you would hypothesize that children who watch a great deal of television behave in ways perhaps are more aggressive than children who watch low amounts of television. If you believe in the catharsis effect, that is, watching TV releases all of those animosities and so on that we have, then you would argue the opposite. That persons who watch a high amount of TV, because that TV acts as a catharsis and they release those feelings of conflict and anger, would be less aggressive than children who watch low levels of television. So researchers generate hypotheses too. And as I've indicated, they're by analogy equivalent to the speculation or the conviction of a prosecuting attorney. However, just as in a court of law, where it's not that proposal that's being tested, it's a proposal of innocence, an assumption of innocence. So in social science, the hypothesis that's being tested is not the research hypothesis, but the null hypothesis. The null hypothesis that says these two scores, these two groups, this population and this sample, do not differ significantly. This will become more central as we look at hypothesis testing. But I introduce it now because it's also important to the issue of experimental error. Are there any questions, any more questions about the null hypothesis or the research hypothesis? Let me sidetrack for a moment or take a step back. We have spent some time, you and I, involved in interval estimation. We have estimated mu. We estimated mu in the first instance, that is, in the situation in which n was large and sigma was known, by adding and subtracting from x bar some number of standard deviations, either 1.98 or 2.56 standard deviations, depending upon whether the confidence level was 95 or 99%. Let us assume that the confidence level is 95%. What is the likelihood of being wrong? That is, what is the likelihood under that circumstance that, remember what we've done is, we've taken this normal distribution, it doesn't look at all normal there, but it's supposed to be, and we've isolated 95% of all the area under that curve. That is, we've isolated 95% of all possible values of x bar, so that there is a 2.5% chance that mu will actually be above y, and there is similarly a 2.5% chance that mu will be below x. Would you agree then that at a 95% confidence level, the likelihood of being right is 95% and the likelihood of being wrong is 5%? Yeah? And when I say the likelihood of being wrong, that more fully means the likelihood that mu is in fact outside of this range of scores, that is either below x or above y. I think we're under attack again. They seem to have motorized equipment this time. They've gone all the way from just tap hammers to this, what sounds pretty ominous to me, this motorized stuff. They're going to come through the wall in a minute. I say God bless you all, and it's been a privilege to have been with you. Alpha is simply the flip side of confidence levels, except that rather than express alpha as a percentage, alpha is by convention presented as a probability, and so is in the form of a proportion. That is, if you establish a confidence level of 95%, there is a 95% chance that you will be right in your estimation, and a 5% chance that you will be wrong. That 5% chance that you'll be wrong can be written as alpha. But if it is written as alpha, then it is written as a probability, 0.05 rather than 5%, 0.01 rather than 1%. So that alpha represents the likelihood that in interval estimation, the estimate will be outside of the range of scores established. Given the interfering noise, are there any questions about that? I take this sort of detour to indicate to you that really we're still talking the same language. Except we're not talking about confidence levels, we're now talking about alpha. But if you were asked to establish an estimate with a 95% confidence level, you could also express that same idea by saying in your interval estimation, set alpha equal to 0.05. Okay? Let's return to our researcher. The researcher knows the value of mu. That is, the researcher knows how frequently, on average, people in the population are victims of violent crime. I think they're digging a trench around us. The researcher then samples randomly a group of elderly Americans and inquires of those elderly Americans how often they have been the victim of violent crime. The researcher then computes X bar, the average number of times this group of elderly Americans has been the victim of a violent crime. You then perform some statistical analysis. But no matter how fancy the statistical analysis, would you agree that at the end of the analysis, the researcher must do one of two things? The researcher must either reject the null hypothesis, or the researcher must fail to reject the null hypothesis. Just as in a court of law, the jury at the end of the trial, at the end of the presentation of evidence and so forth, must either reject the assumption of innocence and return a verdict of guilty, or fail to reject the assumption of innocence and return a verdict of not guilty. Let me, as an aside here, make the observation that you either reject or fail to reject the null hypothesis. You don't either reject it or accept it. You don't accept the null hypothesis. You don't prove the null hypothesis. In a court of law, when a defendant is found not guilty, you haven't proven that the defendant is innocent. All that you've done is you've been unable to find sufficient evidence to overthrow the assumption of innocence. Yes. So would you agree that at the end of the research, at the end of the analysis, the researcher must either reject the null hypothesis or fail to reject the null hypothesis? Gosh. I knew it was not going to come. It was too much pressure. Too much pressure. I knew I wanted to sneeze. It takes years off your life. It can lead to a stroke. We can distinguish, however, between the researcher's decision and what we might call fact, what actually occurred. In a court of law, when a jury returns a verdict of guilty, does it necessarily mean that the defendant committed the crime? No. And likewise, when a jury returns a verdict of not guilty, it does not mean necessarily that the defendant did not commit the crime. So we can distinguish between a jury's decision and what we might call fact. And likewise, we can distinguish between a researcher's decision and what we might call fact. In fact, if you could get rid of all of the error, all of the slop, due to measurement reliability, unreliability, due to problems with the sample, due to problems inherent in the data analysis, if you could remove all of that slop and error, you would have this omnipotent view. And you would know that either A, the null hypothesis was true, or B, the null hypothesis was false. In a court of law, regardless of what the jury decide, the defendant either did or did not commit the crime, you would agree. And that's the case here. Regardless of what the researcher decides, elderly Americans either are or are not significantly more likely to be the victim of violent crime than the population in general. Yeah? You wouldn't have come back from spring break if you'd have known we were going to talk about this, would you? This is why you had spring break, to get you pumped up for this. This is why I give the topic such unoffensive titles on the syllabus. Experimental error. Oh, they'll be okay. That'll be okay. Now we're into courts of law and everything. What this sets up, of course, is a 2x2. If a null hypothesis is true, and if the researcher fails to reject that null hypothesis, would you agree he done good or she done good? Yeah. Likewise, if a null hypothesis is in fact false, and the researcher rejects that null hypothesis, sure, he done good again. Yeah? These, to continue this analogy for you, when a researcher fails to reject a true null hypothesis, this is the equivalent to, this is the analog of a jury returning a verdict of not guilty, and in fact the defendant did not commit the crime. This situation, in which a jury rejects the null hypothesis, that is, returns a verdict of guilty, and in fact the null hypothesis is false, the defendant did commit the crime, everything's all well and good there. Yes. The problem is in these two other quadrants. When a researcher rejects the null hypothesis, but the null hypothesis is true, first of all, would you agree that a mistake has been made? Would somebody like to tell me the analog to this situation in a court of law? Let me rephrase that. Would somebody like to tell me the analog to this in a court of law?
The defendant is guilty, but they don't.
Let me rephrase that. Would anybody like to tell me the analog to this in a court of law?
You're innocent until proven guilty?
No, it's not that you're innocent until proven guilty. That is the null hypothesis. The issue here is, what is the relationship between the decision that's being made and the truth?
They reject it, so the jury finds him innocent, but he did commit the crime.
The opposite. It's the opposite. When a jury rejects the null hypothesis, the jury is rejecting an assumption of innocence. That is, the jury is returning a verdict of guilty when it rejects the null hypothesis. But if the null hypothesis is true, the defendant didn't commit the crime. So the courtroom analog to this situation is one of a false verdict of guilty. This is a type 1 or alpha error. A type 1 or alpha error. A false conclusion of difference. Would you like to move?
I think it's probably going to eventually make its way over there. So. I don't know.
I think next time we ought to fight back. We ought to come equipped to fight back. What with, I'm not sure.
Like the dentist.
Prep sandwiches. You know, these guys have got to be hungry by about now. Just put some sandwiches outside. A type 1 or alpha error occurs when a researcher makes a false conclusion of difference. The researcher rejects the null hypothesis and concludes that X bar does not equal mu. Yes? Perhaps supporting the research hypothesis. But regardless, when a researcher rejects a null hypothesis, she or he has concluded that there is in fact a significant difference between mu and X bar. If that null hypothesis is true, the researcher has made a false conclusion of difference. And that is a type 1 error, or alpha error. When a researcher fails to reject a null hypothesis, and the null hypothesis is false, that is, the analogy here in the courtroom is that the jury fails to reject the assumption of innocence and returns a verdict of not guilty, when in fact that assumption is incorrect and the defendant did commit the crime. This is a type 2 or beta error. A type 2 or beta error. It is a false conclusion of no difference. A false conclusion of no difference. That is, the researcher has failed to reject the null hypothesis, in fact has concluded that there's no reason to overthrow the null hypothesis, which is a statement of equivalence, a statement of no difference, when in fact that null hypothesis is false. So that a type 2 or beta error is a false conclusion of no difference. Are there any questions about error? We haven't finished this discussion, but we've reached, I think, a sort of critical point in the discussion. Are there any questions about the notion of error? In specific, type 1 and type 2 errors.
Well, just with my notes, I've been doing the analogy of the court, and can you give me the analogy for the type 2 or what that would be equivalent to?
The analogy, the question is, what is the courtroom analogy to a type 2 error? And the courtroom analogy to a type 2 error is a false decision of innocence, if you will, or a false decision of not guilty. That is, it occurs when juries return a verdict of not guilty and in fact the defendant committed the crime. Are there any other questions? I'm not going to go on any longer with this. There are people here who are having real difficulty hearing me. What you need to do is this, because we will continue discussion of this issue next time, and it does become an important issue. And I understand that it's a tedious issue. I understand that the language is sometimes convoluted. My advice to you is to read your notes, read the section in the text, and think in terms of, by analogy, a courtroom, where all of this occurs. All of this occurs, and in a courtroom, well, first of all, we recognize the possibility of mistake on the part of the jury. We don't at that point just say, well, we then can't have any court cases at all. Instead, we try to minimize the likelihood of committing either a type 1 or a type 2 error. And social researchers do precisely the same in precisely the same ways, using precisely the same strategies. So I think this analogy of the courtroom is a useful one, in part because it's familiar, and also because that context parallels the context of social research. I will see you on Thursday.